We're switching gears here just a little bit, but we want to find the net charge, or the net force, exerted on, let's say, the 7 microcoulomb charge by a charge of 5 microcoulombs at the origin and negative 12 microcoulombs at this point. Now this point is 0.7 meters along the x-axis, 0.4 meters along the y, in the y direction. This incidentally is the y-axis here, x-axis here. And the negative 12 microcoulomb charge is at 0.9 centimeters, negative 5 centimeters. 0.9 centimeters this way, 0.5 centimeters down. In order to find the net force on this charge, all we have to do is find the force exerted on this charge by the 5 microcoulomb charge and the force exerted by the negative 12 microcoulomb charge and add the two forces. The catch is, of course, that these forces are vectors. These are both positive charges, so we're going to have a vector force in this direction acting on the 7 microcoulomb charge, and a vector force acting on the 7 microcoulomb charge as a result of the 5 microcoulomb charge will have a force out in this direction. Between the 7 and the negative 12 microcoulomb charge, we have a force of attraction, so that we're going to have a force in this direction. So we're going to have to find these two vectors and then add them up as vectors. In order to do that, well, let's just begin by finding the magnitude of the force between the 5 and the 7 microcoulomb charge. The magnitude of the force is given by Coulomb's law as k q1 q2 over r squared. So all we have to do is find this distance here. That distance is easily found using this triangle. We just use the Pythagorean theorem and find that the distance is 0.65, the square root of 0.65 meters squared, which is about 0.81 meters, 0.807 meters, something like that. Then we can get the force F21. Okay, the force of charge Q2 on Q1 we call, remember, F21. And that's going to be K Q2 Q1 over R12 squared, which is 0.5 newtons. Now we see that the force is one of repulsion, so it's in the direction of the red force vector here. And from the magnitude of the force, we can find the x and the y components. Well, from the magnitude of the force and the geometry of this triangle. The sine of this angle is 0.4 meters divided by the hypotenuse, 0.65 meters squared. And the angle that we have here is the same as the angle that this force makes with the positive x-axis. So we're going to get the angle of the force, or the sine of the angle of the force is the same as the sine of the angle of the triangle, which is 0.4 over square root of 0.65. The cosine of the angle, of course, we use to get the x component of the force, and the cosine is going to be 0.7 meters over the square root of 0.65. So F21 is 0.7 over square root of 0.65 times the 0.5 newton magnitude of the force, or about 0.43 newtons. F21 y component, well, that comes out to be about 0.24 newtons. We get that by taking 0.4 over 0.65 times the 0.5 newton magnitude. So now we have the x and the y components of the force of Q2 on Q1. We need to do the same thing with force of Q3 on Q1. So we have to determine the force F31. Well, we'll zoom in on this in a minute, but we see that to go from 0.7, 0.4 to 0.9, negative 0.5, we have to go over 0.2 and down 0.9 meters, so that we have this triangle where we have 0.2 meter displacement here and a 0.9 meter displacement here, so that we have the square root of 0.85 meters separating the 0.7 microcoulomb and the negative 12 microcoulomb charge. And the geometry of the situation is now just given by this triangle. If we zoom in, we can see the quantities just a little bit better. And we calculate the magnitude of F31, just using the magnitude of K Q3 Q1 over R31 squared. R31, remember, is this square root of 0.85 meters. plugging in the values of Q3, the negative 12 microcoulombs, Q1, the 7 microcoulombs, and the R31 that we just saw, we get a force of 0.9 newtons. To get the X and the Y components, we have to multiply the 0.9 newtons by the sine and cosine of the angle of the force. Since the force is in the same direction as the hypotenuse of this triangle, the sine of this angle will be negative 0.9 over square root of 0.85. The cosine will be 0.2 divided by the square root of 0.85. Using the sine and cosine that we get here, we obtain the X and the Y components. Let me point out that it's not necessary to actually find this angle. All we need is its sine and its cosine in order to get these components. Having obtained these results, it's easy to put the vectors together. Okay, we have F31 with its components, negative 0.87 newtons and 0.2 newtons, and F21 with its components, 0.43 newtons and 0.24 newtons. So we can find the resultant vector. We can easily find the X component of the resultant vector. It'll be the 0.2 newtons of this vector plus the 0.43 newtons of this vector, or 0.63 newtons. The Y component will be the 0.24 newtons of F21 and the negative 0.87 newtons of F31, which will give us a negative 0.63 newtons. We find then that the angle of this force, although the picture doesn't show it very accurately, is the inverse tangent of negative 0.63 over 0.63, which is negative 45 degrees or 315 degrees. We can easily determine the magnitude of the force F also, just using the Pythagorean theorem on its two components, and we'll end up with something in the vicinity of 0.9 newtons, and you should go ahead and do that calculation.